Hello, everyone, and welcome to my presentation. This talk is going to be about software composition analysis 101, knowing what's inside your apps. My name is Magno Logan, and I work for Trend Micro Research. Okay, so just a little bit about myself before we begin. I'm an information security specialist at Trend Micro, where I do cloud and container security research. I'm also an application security and DevSecOps practitioner, working with application security since 2011. And I've deployed multiple application solution tools such as SaaS, DaaS, and software composition analysis on many organizations. I also have a personal blog here at katanasec.com, where I publish some articles at least once a month. Those are also my social network there, everything at Magno Logan. Okay, so what is the agenda for this talk, right? So it's a software composition analysis 101. So it's a beginner talk on software composition analysis and what it means, right? So we're going to talk about what is SCA, what is an SBOM, right? Why should you worry about it? Also some supply chain attacks that are related to SCA, some best practices and some tools. And at the end, I also try to do a quick demo of how that would work in your scenario. Okay, so yeah, SCA, right, software composition analysis, and it has many different names as well as library analysis, third-party dependency, or open source security. What does that mean? If you haven't heard about it, it's a solution that application security teams are using to understand the components of their software, understand their version, and understand if there are any public known vulnerability on those components, right? And make sure that they secure those and keep them up to date. So SCA is aimed at providing open source software with governance, security, and also provenance, right? So that's also a big thing here. So understand where those third-party software are coming from, right? If they have been tampered with, if someone has compromised the repository of that developer or of that library that you're using. So that's very important here. And another acronym related to the software composition analysis is SBOM, right? Software Bill of Materials. And I'm gonna talk about that in the next few slides. So to understand, to do software composition analysis properly, usually tools and organizations, they need at least three things, right? They need an application manifest, which gives instructions on how the software should work, right? They need the dependency metadata, which is the metadata related to the dependencies in the code. And they also need the vulnerability data sources, which is a database of vulnerability information like NVD, right? It can be private or a public data source. One thing to note here that's very important on SCA is that not all open source vulnerabilities, right? Security vulnerabilities are published or get a CVE, right? So it's not like a regular vulnerability disclosure process where you go to MITRE, you get a CVE ID and you publish and all that stuff. Sometimes that doesn't happen because those vulnerabilities can be found by developers and by contributors of the open source tool and open source community, and they usually just get an issue on their GitHub and they get fixed and that's it. So that's very important to understand that, because that's going to give you information on the quality of those tools, right? If a tool only looks at NVD, it might not be enough for you to find all the vulnerabilities in your code and your libraries. Okay, so what is like a bill of material, right? I talked about SBOM, software bill of materials, but what is a bill of materials? Basically, as a template here that I have on this slide, it's a list of materials that make up a product, make up an order, right? So here you have different products, different quantities, manufacturers, models, suppliers, and all that stuff. The same thing applies to the software bill of materials, right? So that you have a similar process here. So it's a list of components in a piece of software, right? It's usually software is usually made out of open source and sometimes commercial components, right? So you need to understand from these components, what version are you using, if that version is up to date, if that version of that library doesn't have any public known vulnerability. And so that creates the SBOM, that bill of materials that creates your software, your product. So it also describes the components in a product, right? And it's very similar to ingredients, a list of ingredients in a packaged food, right? So you have like the ingredients there. The SBOM has even more than that, not just the ingredients, but usually have the quantities, like the versions, right? And also might have the provenance. Where does this library or these dependencies coming from? Okay. So you have to create some SBOMs. You have some standards and some resources. The first one here, Cyclone DX, is a lightweight software bill of materials standard, right? It just joined OWASP, right? The Open Web Application Security Project recently. So that's good to know. You also have SPDX, which is another open standard for communicating software bill of material information, which belongs to the Linux Foundation, which is also very well used. And you also have Dependency Track, which is another project from OWASP, allows you to use those software bill of materials to identify and reduce risk in the software supply chain, right? So you can monitor what are your dependencies and if they have any known issues, right? Okay. So why should you worry, right? Why should I worry about dependencies, right? It's not code that's being created by my developers, not code being created by my organization, right? Yeah, that's true, but you're using it, right? You rely on it, and therefore your applications, your security relies on it as well. So it is a dependency, and it's a point of failure on your security approach, application security approach on your organization, right? So here, a report done by Synopsys this year, I think last year actually, was published that 84% of code bases had at least one vulnerability, right? And with an average of 158 per code base. So that's 158 vulnerabilities in dependencies, right? In the libraries and dependencies of that software. That's a lot, right? Even if they are not just all high and all critical, that's a lot of vulnerabilities. And on the right side here, we have a graph that shows the average of open source components per application, right? In 2016, we had an average of 84. And last year, 2020, we now have an average of 528. So that's a lot of dependencies in libraries to keep track of and make sure that they are up to date, they haven't been compromised and all that stuff, right? So you have to be very careful with that. Also, from this report from SNCC, the State of Open Source Security Report published last year, you can see the number of packages created by the ecosystem per year. And we can clearly see here by the graph that NPM has a lot of packages, a lot of libraries that are created every year. So that's a huge dependence there, and a huge problem if you want to use those libraries in your code, right? It's also a huge responsibility as well. And here I have the code cocktail, which was presented by Mark Curphey, which was also one of the founders of OWASP. And in 2018, he presented this code cocktail where it shows that like almost 90% of your code is open source, right? So do you have open source code down at the bottom here, which are usually like the frameworks that you use, right? And then you have the custom code, which is actually the one that your developers create, your developers write for your application. And on the top here, you have the libraries, the dependencies, right? And then on those dependencies, you have direct and indirect dependencies, right? Or transient dependencies, which are usually the hardest problem to mitigate, because it's a dependency that depends on another dependency, right? So what can we do here, right? And that affects not just applications, but also Docker images, right? So you have to be very careful with those libraries and direct and indirect dependencies. And your solution for SCA should be aware of that and understand that maybe you need to update another library to cover and mitigate that issue of another dependency. So why is that important, right? I showed you why should you worry, and now I'm going to show you why is that important, right? So one of the main reasons here, if you work in application security, you probably heard about OWASP, right? And if you heard about OWASP, you probably heard about the top 10, OWASP top 10, right? And as we can see here in the A9, since 2000, the OWASP version 2013, and now on the latest version 2017, using components with known vulnerabilities, A9 is one of the most common security risks of web applications, right? So we've seen this before with the Equifax hack, which was compromised by a library on the Apache struts, right, a few years ago, and that keeps happening. That keeps happening, right? So if there is this, if you're using open source components in your applications, which most of you are, I'm assuming, then you need to be aware of that. And that's one of the risks on your application that you need to mitigate. Here is just an example, right? Comparing a software supply chain with a traditional supply chain. This is a diagram from a company called Conviso back in Brazil, which I used to work for years ago. And they did a comparison, which is very interesting to know and to understand what is the traditional supply chain and the software supply chain, right? So you have your open source, you have your source code and your dependencies, you have your build systems, right? Your CI/CD and your engineers. Then there's the network and communication between those, right? The application repository, right? It could be an artifact repository, it could be image registry, right? And your deployed systems, right? So you have many different steps that your code in your application goes through where they can be compromised. So you need to be very aware of that as well. So what we did, I'm also part of the CNCF security tag team, so technical advisory group. And we have a list, right, of supply chain compromises, a catalog since 2003, right? So the latest ones, 2021 and 2020, shows all the compromises that happen that are related to supply chain and sometimes either the source code, libraries, third-party dependencies, or dev tooling as well. So this is important for you to understand how those previous attacks happen and how to protect against new ones. This is the link of this list. There is more there because I couldn't add to the slides here. So feel free to take a look. And if you have any questions, feel free to reach out. Here is the software supply chain white paper, which was created also by the CNCF tag security or security tag team. It was released this year, and I think in May, so a few months ago. It has a bunch of information on how to secure your source code, securing the materials, the build pipelines. I highly recommend. I was one of the authors and reviewers of this white paper. I highly recommend you take a look with more, a lot of in-depth and technical information on how to protect not just your libraries, but your whole build and your development pipeline as well. Also, supply chain attacks in the age of cloud computing, they can happen in different ways, different scenarios, right? We've seen the SolarWinds attack, we've seen the CodeCov issue and compromise as well, and even the Linux kernel issue recently with the University of Minnesota, right? So it's different ways that attackers can try to compromise systems and inject malicious code in your application, right? In this paper here that we published last year about supply chain attacks on the age of cloud computing, it shows the possibility of attackers compromising the developers' machines and their IDEs, either if they're using their own computer, right, and compromising their own machines, or if they're using cloud IDEs such as AWS Cloud9 and VS Code and other stuff online, right? So if they have kind of a VDI setup, then there's some issues and some security vulnerabilities that you need to be aware, where an attacker is able to compromise those environments and then through that compromise your source code and your application as well. Another thing that was published recently, it was the US executive order, right? The EO, were published last month. And the section, there is one whole section dedicated to the software supply chain security and also software composition analysis in general, right? So one of the items there of section 4, it says explicitly that you need to maintain, right? The US government and all the public organizations of the United States need to maintain accurate and up-to-date data, provenance of software code, or components and controls on internal and third-party software, right? So you need to make sure that you have the most up-to-date libraries, that you know where you're downloading those libraries from, and that you're checking those libraries, right? Checking their hashes to make sure that they have the proper integrity, they haven't been tampered with, right? And maintain that. And so it seems kind of basic to us, but it's very important as the application grows and software becomes more complex, it becomes harder and harder for an organization to do that, right? Especially public organizations that sometimes don't have enough resources and budget to use the proper tools and have enough dedicated people to do that. So here's just some examples on tools that you can use. Just a few lists here. That's not an extensive list. You can look more resources online. But the ones that you can start with, if you don't have enough resources and budget, right? There is the OWASP dependency check, which is also was also created by OWASP, and it's free and open source. And you also have the retired.js, which checks your JS libraries, JavaScript libraries for any library that can be outdated or vulnerable. Besides that, you have SNCC, right? We're at the DevSecCon. It's a SNCC conference, and SNCC is free for open source, right? So you can use that you can use SNCC to connect to your GitHub repository, and you can scan any repository that you have that's public, that's open source, right? Using that SNCC technology, we also have the open source security by Trend Micro, which ties together into our Cloudland platform, and that's the one that I'm going to demo in a bit. And there is also Veracode and Black Duck and other tools as well. Okay, so this is the demo time. I hope I still have enough time for doing the demo. And basically what we're going to do, right? We're going to check into a repository using the open source security by SNCC and Trend Micro, and just run a simple scan to evaluate the libraries and vulnerabilities in that source code. Okay, let me just move to my demo. So here we have the open source security by SNCC at the Trend Micro Cloud One platform. Just here, it's an integration, right, between SNCC and Trend Micro. just a quick demo on showing, and this open source, this scanning that I'm going to do is on an open source project. So let me add a new one. So basically, what the first thing that you want to do when you start using SNCC or the open source security by Trend Micro, you need to do an integration, right? So you need to connect that with a repository, a source code repository of your choosing, right? To import that so SNCC can read that data and scan it, right? I already have my GitHub configured here, so I don't need to do that. So I can add a new project here. Let's see. I can go to GitHub, right? And I have many different open source here, so might take a while. I know I fork a lot of projects, right? So it's fine. Let's see if I can search here, search by name. Yeah, Java goof trends. So I'm gonna use this application that's hosted on my GitHub that I forked it, and I'm gonna use that to scan through SNCC. Here, if you have custom locations, right, it's going to the tool is going to look for the file where it talks about the dependency metadata, right, which libraries and versions you have in your code, and it needs to run. So it's going to check for that. If it's not a default location, then you can add that here. But since that's default, I'm going to use that and just add select repository here. Okay, now that I added, right, the open source security is importing that project and start scanning. And as we can see, quickly detected some issues here. And I can see that there's 46 high vulnerabilities and 44 medium vulnerabilities, right? So I can view the report here, and it has a kind of a dashboard. Let's see if it's going to show me here. Might be still loading the information. So let me go to dependencies for now. And I can filter here by any status. Let's see, just order here by number of vulnerabilities, right? Oh, I can see here, these are some of the dependencies that I have in my code, in my repository, and I can see that where this version was last, but I can see the current version, right, which I'm using, for example, 2.3.20. I can see what is the latest version of this library, right, which ideally I should update to the latest version if possible, right, if it doesn't break any changes. That's the latest publication, the latest version of that library. So that's when this latest version was published. Right? And here I have the vulnerabilities, right? So 20 high vulnerabilities and 2 medium. We also can see the licensing, right? I didn't talk much about it, but licensing is also important, because if you're breaking the software license, there can be issues, legal issues regarding that, right? If you're using open source for commercial reasons, and you're not sharing the code, or depending on the license, you're not following the software license as well. So you need to be aware of that. Yeah, so it shows here the dependencies of issues, right? We can see other libraries as well, right? And that already gives us, this is the bill of materials, right? This is basically the components that make up my software, my application, and I can quickly see which ones are most vulnerable and which ones I need to focus first to fix those vulnerabilities, right? Let's see, go there. Issues. No issues here. Let's see if there's any licensing issues. Let's see. No major. I think just one mediums here, like dependencies, not much. Let me go back to the dashboard. Let's see if that's loading. Not yet. Okay, that's fine. Yeah, so we can see how easy it is for someone to just start using open source security and SNCC and quickly import their projects and start scanning them, right? And finding those vulnerabilities, right? I'm sure there are many other features that we could show here, but there's not the goal of this presentation and there's not enough time. So I'll just pause here and go back to my presentation to finish, and then I'll open up for questions, and I'll be available also on the chat and during the conference during the whole day. Okay, so yeah, we did the demo, right? We showed here how it works, how it's important to check for your dependencies and your libraries, check for not just their versions, right? If they're up to date, also if they have public known vulnerabilities, but also the licensing, it's also important, and you might face any kind of legal issues if you break software licenses, right? So yeah, that concludes my presentation. Here are some references. I'll be published in slide after this talk, and thank you very much. Yeah, thank you.